This question is binomial expansion, and you have to remember binomial expansion where the power n is not a positive integer. So it is like this. 1 plus b to the power n is 1 plus nc1. Instead of nc1, we write n. So b to the power 1 plus nc2. Instead of nc2, we write n minus 1, 2 factorial, which is 2 into 2. And b to the power 2 plus nc3, which is n minus 1, n minus 2 divided by 3 factorial, which is 3 times 2 times 1, which is into b to the power 3. So this is, and it goes on and on. So this is the binomial expansion, and for where the n is not a positive integer. So what we can do over here is, in question number 8, we have to expand that. So first of all, 1 by 2 minus 5x to the power 2, if you bring it upstairs, it becomes 2 minus 5x to the power minus 2. Now we have to take this 2 common and make it 1. Remember, it has to be 1 plus variable to the power n format. So if we take 2 common, it becomes 1 minus 5 by 2x, and the whole power is minus 2. That means if you separate the power 2 to the power minus 2, this turns out to be 1 minus 5 by 2x to the power minus 2. So 2 to the power minus 2 is 1 by 2 square, which is 1 by 4. Now let's break this down. First of all, the value of b over here is minus 5 by 2x. So 1 plus nc1 is n, which is minus 2, b to the power 1. b is minus 5 by 2x to the power 1, plus nc2 is n minus 1, which is minus 3, divided by 2 into 1, which is 2, and b to the power 2. Now we have to expand this up to x squared. So this is done. So we can simplify this as 1 by 4, 1 plus 5x plus 6 by 2 is 3 times 25 by 4 x squared plus dot dot dot. So now let's write down the final answer. It would be 1 by 4 times 1 is 1 by 4, plus 1 by 4 times 5 is 5 by 4x, plus 1 by 4 times this is going to be 75 by 16 x squared. Now this question has another part where we have to do some sort of an expansion. Remember, in binomial expansion, we don't have any division, we have multiplication. So when they say, given that the binomial expansion this is this, what it means is that we have to do a division. That means we can write it as 2 plus kx. Instead of divided by 2 minus 5x to the power 2, we can write 2 minus 5x to the power minus 2. So this would be 2 plus kx times, now we just expanded this, and this turns out to be, so this is what we got from the previous expansion of 2 minus 5x to the power minus 2. So all we have to do for this division is we have to multiply this but up to x squared. So we don't have to use any term other than x squared. So let's multiply this. So this is going to be, first let's multiply this with 2. So 2 into 1 by 4 is 1 by 2, plus 2 into 5 by 4x is 5 by 2x, plus 2 into 75 by 16 is 75 by 8 x squared, plus now kx into 1 by 4 is k by 4 x, plus kx into 5 by 4x is 5k by 4 x squared, plus kx into this becomes x cubed. So I'm going to ignore this. So now if we bring all the terms together as coefficient of x squared, and constant, it turns out to be 1 by 2 plus, if we take the x common, 5 by 2 plus k by 4 x. Now if we take the x squared common, it would be 75 by 8 plus 5k by 4 x squared. So that's what it turns out to be. Now in question number B, we have to find the value of k. Now in order to find the value of k, we can write it down as the coefficient of x, which is 7 by 4. So we can write, for x On one side we have x has a coefficient of 7 by 4. On this side we have 5 by 2 plus k by 4. So 5 by 2 plus k by 4 equals to 7 by 4. That means k by 4 equals to 7 by 4 minus 5 by 2, which turns out to be minus 3 by 4. That means if we send the 4 to the other side, the 4 cancels, k equals to minus 3. Now question number C. For x squared, if we compare x squared, so x squared has a on this side, on the other side we have 75 by 8 plus 5 by 4k, and we already know k is minus 3. That means 75 by 8 minus 15 by 4, and that turns out to be 45 by 8. So a equals to 45 by 8. Question number 4, we have a shaded area or a shaded region, and the idea is we have to find the volume when this object is rotated about the x-axis. Remember, flat surfaces don't have any volume. We have to rotate it about the x-axis, about 360 degree, means in complete circle, and then it would form a shape something like this. So if this is the shape and we have this, so if you rotate it, the shape would be something like this. So this imaginary solid, it would have a space known as the volume space, and that's what we are going to find. So the rule for finding the volume is volume equals to integration. So we have a limit from 0 to 2. So 0 to 2, and we have this slice, and each slice is pi y square dx. That means this is the radius of the cylinder, so this is y. This is the height, which we call dx, a very small height. So pi r square h, so pi y square dx. That's how we find the volume. So if we put the value is going to be 0 to 2 pi. Now y square is going to be square root of 2x by 3x squared plus 4 whole squared dx. So this turns out to be, if you bring the pi outside, so volume equals to pi 0 to 2. Now square root of 2x divided by 3x squared plus 4 whole squared is only 2x divided by 3x squared plus 4. So we are here right now. Now if you take a look at this integration, definite integral, because it has a limit, we are stuck. We cannot simplify this. If it was in this format, suppose 3x squared plus 4 divided by twice x, we could have written it as 3x squared by twice x plus 4 divided by twice x. Then it would have been 3 by 2x plus 2 times 1 by x. We could have simplified this, but it is not in this format. So we cannot do anything about it. Another way of dealing with algebra is partial fraction. But this is not partial fraction because this is quadratic. Downstairs it has to be linear. So we are stuck with this. So what do we do when we have an algebraic fraction which cannot be simplified or cannot be broken down into partial fraction? We have to deal with it using a special rule, and this is a very specific rule that you need to remember for situations like this, which is quite irregular. So this is a situation when you have to integrate f prime x divided by fx, meaning upstairs we have the derivative of fx and downstairs we have fx, then the answer is going to be ln of fx plus c. That is the rule. So you have to remember this special situation wherever you're stuck with algebra that cannot be simplified or broken down into partial fraction, you have to use this rule. So let's check. The derivative of 3x squared plus 4 is 6x. But upstairs we don't have 6x. Upstairs we have only 2x. So where do we get 6x? We have to make sure we multiply it with 3. So if we do this, 0 to 2, 6x divided by 3x squared plus 4 dx, now it works. But the problem is, then the math doesn't make any sense, because in the previous line we had twice x, now we are writing 6x. It cannot be done. So how do we write it as 6x so that it looks like it becomes twice x? So we can just write 6x by 3. So it means we can write pi times 1 by 3, 0 to 2, 6x, 3x squared plus 4. All we did was change the algebra, that's all. Nothing else. So instead of writing twice x, we are writing 6x divided by 3. So it is same as twice x. Now we have changed the format, we can do the sum. So pi by 3. So integration of, this is fx and this is f prime x. So the rule says it is going to be ln of fx, which is 3x squared plus 4. So that is the idea. So we have the limit 0 to 2. So it turns out to be pi by 3 ln of, if you put 2 here, this would be 3, 2 squared plus 4 minus ln of, if you put 0 here, 3, 0 squared plus 4. So it would be pi by 3. So this would be ln of 3 fours are 12. 12 plus 4 is 16 minus ln of 4. So this turns out to be pi by 3 ln of, we know log a minus log b is log a by b, C2 rule. So this is going to be 16 by 4. So pi by 3 ln of 4.